In our project, we wanted to understand how we can make the most of the multiple benefits farmland agri-environment interventions provide. Using pollinators as a case study and focusing on three of the most common interventions, we investigated how different combinations of these interventions simultaneously affect environmental, economic, and social benefits, and how this might help us tailor interventions to balance benefits in different landscapes. 72% of the UK is farmland. Not only must it provide food for human consumption, but it must also support biodiversity, which in turn underpins the ecosystem services that benefit us all. It must leave space for recreation and often represents a physical manifestation of our cultural heritage. This means any land use change will impact multiple benefits. Where these changes are subsidised through agri-environment schemes, it's essential to take this into account to make sure that interventions are cost-effective and provide benefits where they are needed most. Reduced hedgerow cutting regimes, grassy field margins, and florally enhanced margins are three of the most common agri-environment interventions. They can all help support biodiversity, especially pollinators, who benefit from the floral and nesting resources they provide. They also impact cropland income, through the increased pollination service these pollinators provide and the subsidies farmers are paid to implement them. Finally, by changing the way the landscape looks, they also affect social aesthetic benefits. Crucially, all three interventions will affect these three different benefits in slightly different ways. We wanted to know what are the best combinations of interventions to balance these three benefits in different landscapes. To do this, we combined three benefit models. We used a validated process-based model to simulate the life cycles and foraging behaviour of bees, and so predict pollinator abundance. We then fed the predicted bee visitation rates into a cropland income model, which sums up the total income from any agri-environment subsidies, plus the income from crops, where the yield of pollinator-dependent crops like field bean and oilseed depends on the level of pollination service they receive. Finally, we modelled visual aesthetic benefits using public preferences for landscape features derived from an online survey conducted by the Resilient Pollinators project. We then selected 9 study landscapes with different amounts of arable land and virtually added different combinations of interventions to the digitised landscapes. We then ran our combined benefit model to calculate the change in bee abundance, visual aesthetics, and cropland income in each scenario. We could then pool our results to work out how the level of each benefit depends on the amount and type of interventions. We found that people and bees were in good agreement. In terms of visual aesthetic and bee abundance benefits, the more enhanced margins and hedgerows the better, but people had a preference for more flower margins than grassy margins. The results suggested cropland income decreased slightly with increasing margin enhancement under our assumed payment rates, but that this could probably be overcome by locating these interventions in less productive areas of the field, while hedgerow enhancement was predicted to significantly increase cropland income. If we place equal value on each of our benefits and assume a 1% change in bee abundance is of equal importance to a 1% change in aesthetics or cropland income, we can then add up all three to look at which intervention combinations maximise the net benefit in different landscapes. In landscapes with low arable cover and lots of semi-natural habitat, this is achieved by prioritising aesthetic benefits. This means lots of hedgerow interventions and a bias towards floral margins over grassy margins. This is because cropland income is low in these landscapes and they already support lots of bees. In moderate to highly arable landscapes, it's achieved by prioritising biodiversity benefits. This requires more equal proportions of each type of intervention. Only in the most intensely arable landscapes on the most productive land does it become important to balance economic demands by switching back to a bias towards hedgerow enhancement, which increases cropland income, and floral margins, which receive higher payment rates. Overall, the results show the more interventions, the more cost-effective the agri-environment scheme becomes at delivering these three benefits. But where uptake is low, interventions should be spatially clustered to help support bee abundance in particular. Our project has shown how sophisticated ecological, economic and social value models can be combined to help assess the multiple benefits provided by landscapes. Our results indicate how agricultural land use policy and practice might target common agri-environment interventions to balance multiple benefits in different landscapes. The modelling framework can easily be expanded to incorporate other benefits in land use systems with competing environmental, economic and social demands.